So the next topic of discussion is going to be EIGRP manual summarization. Now let's pretend there are three networks that exist in our topology, and I'm going to create them in a little bit. And they are networks 30.10.8.0 with an IP address .8, and then network 30.10.9.9 with a network address of 30.10.9.0, and another network with a network address of 30.10.10.0 with the IP address being .10, since these all three are /24 networks, or 255, 255, 255, 0. Now, let's say these networks exist in my topology, and some other network administrator tells me, or some other network engineer tells me, please stop cluttering up my routing table with all three of these networks, and please summarize them into one address and send me that one address. So how do I go ahead and summarize three different networks, into one address? Well, let's look at which octet is different on these three networks. So this network is network 30.10.8.0, this network is 30.10.9.0, and the last one is 30.10.10.0. So if you see, the first octet's the same, the second octet's the same, it's the third octet that's changing. So I have drawn out three octets. I've drawn out the third octet for each one of these networks. So this is going to be the value 8 in the third octet network. This is going to be the value 9 in the third octet network. And this is going to be the value 10 for .8, .9, .10. Now, how do I get 8? Turn the 8-bit on, and the rest of them are zeros. How do I get 9? I get the 8 and the 1-bit on, and the rest of them are zeros. I turn the 8 and 2-bit on to get 10, and the rest of them are zeros. So, as you see, my ones line up at the 8-bit value. So, my summarized network address would be 30.10.8.0. And my mask is going to change to, remember, this is the third octet for all three networks. My mask is going to change to 255.255 because the first two octets are completely masked. Is the third octet that we're working in. So at the 8-bit value, if I add all these up, 128 plus 64 plus 32 plus 16 plus 8, I get 248.0. Or a /8 plus 8 is 16 plus 17, 18, 19, 20, 21. Or a /21 network. Now let's go ahead and see how this works on our lab.